So let's start with this Kubernetes Community Days Colombia. In fact, we should be there, but some things happen, and then we need to do it online. Today we're going to see, a Tekton and ArgoCD talk that they for the cloud native CI/CD. We'll see how to use a cloud native approach for implementing continuous integration, continuous delivery, and continuous deployment in Kubernetes. So my name is Alex Soto. My Twitter is Alex Soto B, and my email is sotoy@redhat.com. If you got any question, just can follow me on Twitter and ask me there, or send me an email. I'm the co-author of this book, and the good news for you is that if you like all these GitOps things, you can download it for free, the GitOps cookbook. You all need to go to developers.redhat.com, and then you go to the ebook section, and you can download this for free.
All right, and then I'll introduce myself as well. I'm Kevin Dubois. I'm in the same team as Alex, as developer advocate at Red Hat. And I've been, in the software industry for about 18 years, building and delivering software applications. Unfortunately, I don't speak Spanish, maybe a little bit if I've had a few drinks, but yeah, you can find me on all these channels, and I'm really passionate about the developer experience with open source, and open source is something that that we do a lot of at Red Hat. That's all we do at Red Hat, and so pretty cool company to work at.
Okay, so let's start a bit, right? We know that when we are developing, we've got the inner loop and the outer loop. The inner loop is the space of the developer. So the developer just, do some code, can build and package, can test application, can debug in case of errors, and finally, usually they push the code to Git or to a branch, or create a pull request, whatever. This is the inner loop. This is the space of the developer. But there is another space, which is the outer loop. The outer loop is where you maybe code review, finding some security issues or whatever. Then usually you build your application that is your CI/CD system, right? Maybe Tekton, it's a really good option in Kubernetes. Then you will run all the tests, and finally you will deploy your application to, let's say, production, but of course it could be staging environment, or pre-production environment, security environment, performance environment, whatever. Okay, so that's important to notice that today we're going to talk about the outer loop. Of course, we could do another talk with inner loop, but today let's focus on the outer loop, this part of the scene. Because basically, what is CI/CD and CD? So it's continuous integration, continuous delivery, continuous deployment. Maybe you are already in here, but continuous integration is the part where we build the application, we run some tests, not all the tests, just needs to be tests that run within 10 minutes, all of them. So usually unit tests, maybe one or two end-to-end tests, component tests, and so on. Then there is security checks, and finally there is the release. And in this case, the release is publishing this artifact to a repository. Nowadays, in the containers world, what we are doing in this release phase is pushing the container into a container registry. Of course, then it comes the continuous delivery part, which is the deploy to stage and deploy to production. And of course, if you're using continuous deployment, then what you're doing is no manual step, just deploy automatically to production. So the big difference between continuous delivery and continuous deployment is the step to move to production. In delivery, it's manual, so someone needs to push the button and approve. And in the continuous deployment, you are automatically moving to your workloads there. Okay, but you can see that. Let's see a bit of an example of a continuous delivery. But first of all, let's play a game to just understand a bit everything. Okay, so this game is this application is a racing game. You can see that. Here is the dashboard, okay? And basically, this dashboard contains this path, right? And you see that there are two cars. One that is yellow, another one that is blue. And it means that because we're going to be two teams, okay? Two teams, team yellow, team blue. And you in your screen, because this is an interactive and we need you, you're going to have this windmill that you need to push to generate power. So all the power that the yellow team generates will go to the yellow car. All the ones from the blue will go to the blue. And you know, the goal of this game is to make a complete lap to this circuit until you get to the goal. So cars needs energy. Okay, under the hood, basically, just if you want to understand the architecture of this game, basically you've got here your phones, right, where you're going to generate, you'll see in a few moments, no worries, but it will generate a username for you, then you will connect to the game and you will start, you know, generating power, and you'll see how the dashboard is updated. And all this backend is used by using Kafka and Quarkus. So, Kevin, do you have the, maybe you can stop presenting and sharing the dashboard so they see exactly. But before that, take your mobile phone, which is here, okay? So this is my phone, okay? Then go with your camera and scan this QR code, okay? And when you scan this QR code, yeah, oh, Kevin, you are in the yellow? Oh, you're in the yellow, I'm in the blue, okay? I'm in the blue. So we are in different teams. Now, all of you needs to scan this QR code and you will be assigned to the blue or to the yellow. Then,
okay, so I'll share my screen.
Yeah.
Yep, perfect. Let's do that real quick.
So I hope that everyone now is having something like, you know, a rolling car here.
Okay, so everybody sees the racing game on the screen. I see.
Yeah, we see.
Some people are signing up. All right.
Yeah, let me see if I see. I cannot see myself, so it means that we've got a lot of people there. Okay, now, the thing is, just in this, in a few moments, you'll see how Kevin pushed the play button, and when he pushed the play button, which is here in the bottom left, okay, we will need to stop tapping the mobile phone. We're doing this to make the car move, okay? So please, blue team, do it super quickly, because we need to win.
No. Team Yellow needs to do really well, okay? I'm counting on you, okay? If anybody didn't scan the QR code, don't worry, we'll play this game again in a little bit. So don't worry if you didn't get to play. But all right, everybody ready? 3, 2, 1, and go. Tap.
Come on, blue.
Come on. Oh, no, come on, Yellow.
Come on, blue. Yeah, we can do it. Come on.
Come on,
we're generating a lot of power. I see that Zorman is generating a lot of. Oh, come on.
It's so close.
Yeah, that's super nice. Okay, super nice. We made it. Okay, so great. Let me. You said that, yeah, this game was really fun to play, right? I mean, that we spent some good time. But you say, this game and continuous integration, continuous delivery, you know, what's exactly this? Well, because, you know, managers are here to, to complicate our life. And they said, hey, Kevin, Alex, I'm the product owner. I've got a great idea. What we need to do is add a new feature to the game, which is that now, instead of push or tapping the screen, we want to shake our phone to generate power. Okay, so we want to get the gyroscope and the of the phone and generate some power and send it to the to move the car. Okay, so of course we are developers. We are super efficient. We're going to see in a few moments how we can do this. Okay, but for now we are super efficient, and we're just here. We have the depths. We just implement all the new feature. Okay, that's fine. Of course, it takes us some time, and then at Friday at 4:45, we say, "Oh, that's all. Just coded. Hey, ops team, deploy this game." Because, you know, our manager said that they wanted to have it as soon as possible, but we as developers have done all the job. The problem is that, okay, we have the developers, we implemented everything, but maybe we missed to explain to the ops team how to deploy this to production, which configuration properties they need to set. Okay, so this can happen, right? And then we'll get back again to this. Inner loop is perfectly fine. Outer loop, okay, we need to figure out how to do it. And also, we are using, of course, Kubernetes or OpenShift for deploying to production. So we need something that is native to Kubernetes and OpenShift, something that helps us to implement continuous integration and the continuous delivery. And in this, for implementing the continuous integration part, we've got Tekton. Okay, Tekton is a cloud-native CI/CD system that basically is built for containers and runs on Kubernetes. You'll see that basically what we got in Tekton is that each of the steps of our pipeline is implemented inside a container. It's run inside a container, which means that it's a serverless approach. Basically, we do not need to maintain anything. Everything that's inside a container. So we just run a container and this container will do things. For example, compiling the project or packaging the project or testing the project or creating a container. Okay, and you can see that this approach helps a lot on microservice architecture and for distributed teams, because it means that each of the teams can have implemented its own pipeline. And as I said, Tekton is in Tekton.dev. It's a mature technology, okay? And basically, you need to be really clear about this, because basically Tekton is typed, it's decoupled, it's cloud native, and it's declarative. And the concepts that you need to know about them is that, first of all, it's the step, okay? The step is just a command that you're running inside a container. For example, compile a Java project, do a package, Maven package, or create a container, or run tests, okay? So you can see that what you're doing inside a container is running commands. So you need to have these tools installed inside the container. But at the end, this isn't a step. Usually, our pipelines are composed by more than one step. For example, we want to do a git clone, so we want to clone the project, and then we want to compile it. So maybe we want to get Maven compile. Maybe we want to do a package, Maven package. Maybe we want to run tests, Maven test. So you can see that there's a lot of commands to run them. And this is exactly a task. A task is a list of steps that they are executed in sequential order. But, of course, a pipeline is something more complex. Usually a pipeline needs to run with more than one step, and this is more than one task, and this is a pipeline. And then the steps, the task, and the pipeline is just the definition of our pipeline. And at the end, we need to run it. We need to, in Jenkins, when we push the play button, that's the thing, okay? In Tekton, we need to create a task run or a pipeline run. I know that it's a bit complex, but you'll see in a few moments the code. Here is the code, okay? This is how you define a pipeline. You define a pipeline that says, okay, look, there is some task. One task is doing a git clone. Then maybe there is another task for, doing the clone, compiling, and so on. Of course, there is also the Tekton Hub that basically it's a hub for downloading these tasks, so you do not need to create tasks on your own. Maybe you can reuse them from this hub. And there's also a Tekton CLI tool, which is called TTN, that helps you to view and create these elements, okay? But, sorry, I know that's quite quickly, but we want to run again this cool game, right? And it will show you also some links to, to learn more of this. But now it's time to understand another part, because here with Tekton, we are just building and sending our container to a container registry, but we need to do more. We need to deploy it to production, and this is what Kevin is going to explain to you. Your stage is yours, Kevin.
Are you muted? Okay.
The classic, you're muted. Sorry. So I was saying, with CI/CD, it works really well. With Tekton, you can define your steps and your tasks to deploy something. Build your container image. You can push it, and technically, you could even say, "Hey, I have some definition to deploy it to production." But the thing is, with regular CI/CD, it's kind of a one-way street, right? It means that you run through your pipeline, and then the pipeline ends, and those resources get torn down, because in Tekton you don't have any running resources. You just have the definitions that then get run in a container, and then that container gets torn down. But then, once the pipeline is done, it's done. And so what about, kind of monitoring our system and seeing who has done a change, who made a change, and what was changed, and how do we configure everything? So that's something that you can do with GitOps. So it's something that's complementary to your, let's say our classic CI/CD, even though we had a really cool example of using Tekton as kind of a very cloud native serverless CI/CD. So GitOps basically, it means that you have Git, of course, because it's in the name, and Git is your single source of truth. So you're going to define, for example, how you're going to deploy your application, how many instances of your application you want to run, what kind of configuration, maybe you have config maps and secrets and volumes and all that stuff. And so you define that in YAML, basically, right? Because in, let's say, Kubernetes, it's typically you will define things in YAML or maybe in JSON, but you can store all those definitions of your desired state, what you want to have running in whatever environment, in your development, in your staging environment, in your production environment. And so you define that all, you push it to Git, and then that is your single source of truth to then treat everything as code, even your configurations and your definitions. And that allows you to do, operations through Git workflows, just the same way as we develop our code. So, like if we do, if I'm doing my inner loop development and I push my code, then you can see, hey, Kevin pushed this change at this hour, and these are the changes that were made, and we can do pull requests and merge requests, and use that whole process, that we're used to with Git when we're developing. But we can actually use it for, kind of more operational concerns, platform engineering / ops concerns. So that makes it really, really cool to use, GitOps as a way to manage our resources. So the difference between CI/CD and GitOps, as I kind of already was saying, is that you have, CI/CD, which is, kind of one way. You have your desired state. You go through your pipeline, whether it's with Tekton or with Jenkins or with Spinnaker or whatever, and then you make those changes, and that's it. With GitOps, the idea is that you define your desired state, and then with a GitOps, whether it's an ArgoCD or a FluxCD or whatever, is going to monitor, hey, you made some changes that you pushed to a Git repository, and those changes are not reflected in your environment. So we're going to remediate our states to match whatever you have defined. So you can do this automatically, or you can have GitOps notify you of that change, and then that way we can see that always what our desired state is should match with our state of our cluster, and then we can remediate if that's not the case. So then we can change, we can push our changes to Git and automatically observe and make those changes through monitoring, and that happens continuously. So all the time, GitOps is monitoring your system, and that also means that if you make a change on your, let's say, your production system that you didn't push to Git, you're actually going to get either a notification, or GitOps can actually reset it to whatever you had in your Git, so that you don't have those situations where somebody made a change and then they forgot that they made that change, and then something else gets pushed, and all of a sudden you have production problems, or somebody made a change and you don't know who made it or when they made it. But because with GitOps, you have it all in your Git repository, where, again, because of your Git history, you can see who changed something, when they changed it, and what they changed at all times. So that's, the kind of handy way of doing GitOps. So we have our game, right, that we had, and we had to tap. But let's say that we want to do some really hardcore development, and instead of tapping our phone, why don't we make it a little more realistic? So because we have windmills that generate clean power and its movement and everything, And so we're gonna, instead of tapping our phone, we're gonna shake our phone to make the cars move. So, we're gonna release that new feature with CI/CD and with GitOps. And so let's do that.
Yeah, Kevin, I already did the pull request to to not get out of time. Okay, so you can show them the change if you want, because it's already done.
Yep.
You can show also the YAML files if you want, the Tekton YAML files and so on, and the final result.
Okay, so you
It's not
made
a pull
the
no, it's
you made the change.
I missed to push the create a pull request. But,
okay, no worries.
Yeah,
okay, so here we can see. Yep. So we can see 3 minutes ago that Alex made the change. So let's see. I'm reviewing his changes, and yeah, he made some really big changes here. We can see that he changed tapping to false, and he changed shaking to true. And so that's our big feature. That of course there's code behind it. And so these are the feature flags to control it. But let's pretend that we did all the development too, and now we're making our change. And so by pushing this, and let's say that I did the peer review and I approved it, and so now we can see that because there's a webhook attached to this Git repository, we're going to see that, and this is OpenShift, so it's an implementation of Kubernetes. And so OpenShift, what's nice is that it has Tekton, kind of built in, so I can show that pretty easily. But you could actually use Tekton on Kubernetes. You don't necessarily need OpenShift. It just makes it a little easier. So here we can see that our pipeline already ran, and we can see that Git clone happened, and then a Maven build happened, and then we built a container, and then we updated our repository. So we can see here that that we pushed our changes to our repository. So let's make sure that this actually happened. So here we have a Quay registry, and we can see, yep, 3 minutes ago. So we went through our Tekton pipeline. We went through those steps, and it created containers, and then built the application, built a container image, and then pushed it. And we can see here that sure enough, it pushed our container image with a different digest, right? And so then we have a different repository that has the code changes. So we have quinoa wind turbine manifests. And so this is the best, in my opinion, the best way to do GitOps is you have one repository for your code, and then a separate repository for your configuration changes. And so in this case, that's what we did. You could have them in the same repository as well, but here you kind of have a separation of concerns. So here we can see that, again, 3 minutes ago, we updated a manifest. So that also happened automatically in our CI/CD pipeline to update the digest here. So if we look at the history, we can see that the digest was changed by the Tekton bot to match with our new image. And then what happens in ArgoCD, so ArgoCD is an implementation of GitOps that also is running on our OpenShift cluster. So we can see that, if we refresh just to make sure, we can see that, well, already the changes were made. So you can see succeeded a minute ago, and this is very small. I can make it a little bigger here. So we can see succeeded a minute ago. So actually it manages all the resources of our application. So we have a service and a deployment and a route, which is kind of like ingress. And it has, our different replica sets, and we can see that a new replica set was created a minute ago to deploy 5 new pods with the new version. Okay, so if we go back to our game and well, let's see. I think my QR code is somewhere hidden, so I'm gonna go find it. Here we go.
If not, no worries. I mean, that you will see something that it says waiting game again. So, I mean, you need to refresh, okay? You just push refresh, and you'll see that says something like enable shaking, okay? This is because, we need to enable the gyroscopes of the phone. So just push enable shaking. It will say, do you allow me to send gyroscope information. You can say yes, no worries. We are not storing anything. Nothing. There is just we're sending just gyroscope. Okay, and then we are back to the waiting here. Okay.
Okay. So hopefully everybody had a chance to scan the QR code who maybe hasn't played yet. So I'll give you maybe 20 more seconds or 10 more seconds to scan the QR code to play the game with us. And 5,
remember,
4.
yeah, you can also refresh. You can also push the refresh.
Yeah, if you already had it, then you can just hit refresh. Yeah. All right. So I'm assuming that everybody scanned it. Unfortunately, when we're not in the room, it's a little harder to see. So I'm going to go back to the game, and we've now released our new version. So I need to log in again. And so let's see if the players are loading. Yes, so we can see, we have more players this time. We have 13 players in Team 1 and 9 in Team 2. And Team 2 is the best team, of course. And don't worry about the number of players. It's just the average of all the players. That does mean that if you have the game, you have to shake, okay? Because otherwise you're dragging the team down, okay? So
and no worries, because there is a map function that depending on the number of the members of the team, you need to generate more or less power to advance the same, okay? Right. But now remember that you need to shake your phone, okay? Shake. Beware, catch it hard, okay? Don't throw your phone to the...
Don't throw your phone, so hang on to it. Okay, so 3, 2, 1. Okay. And shake your phone. Shake. Wow, look at those cards. Come on, Team 2. Come on, Team 2. Shake harder. Oh. Team 1 is too good. I'm 6th. What are you, Alex?
I'm wait. Oh, I am DG something. What am I? Oh, 9, number 9.
9. Yeah. 9, yeah. All right. So good job to the player with the username Kirvan. You won the game. If we were there, we'd give you a prize. Unfortunately, you'll just have to come visit us in Europe, or maybe we can come to Colombia next year. Yeah. All right. So basically, what we showed here was a way to deploy our game using Tekton, right? So we went through the pipeline to build an application, to build a container image, to push it to a registry, and then change the tag of our manifest. And automatically, GitOps noticed that there was a change in our manifest and then updated our cluster automatically. We didn't have to redeploy anything. It just said, hey, your desired state has changed, so let's change our cluster. So it all did that automatically. So I'm going to go back to our slides here, and my computer is running a little bit slow, so I'm a little bit delayed with my slides, which is fun. Okay, so we saw that Git is the desired source, is the source of truth. We did our live coding, and then basically here's a representation of what we did, right? So we have our source Git repository where we made our changes, our new release of our shaking feature. We went through the CI pipeline. We pushed to the image registry. Then we created a pull request that Alex approved himself as as a bad developer. And so then we updated the Git repository with that change. Then we had our GitOps that pushed all the changes automatically. So that happened kind of all through GitOps. And so the GitOps implementation that we were using was ArgoCD. So ArgoCD is a tool that you can use to do GitOps. That is declarative GitOps that you can use with Kubernetes. For example, in OpenShift, it's one of the it's the tool that's used by OpenShift GitOps, and so it sees in Git and then does everything just like we were saying. And so that's basically our session. So we went through it very quickly today. We weren't sure if we had 30 minutes or 40 minutes, but that means maybe we have some time for questions. But I have a few more slides with some resources. So first of all, if you want to try out OpenShift, here's a free way to use it. So you can use the OpenShift Sandbox. You go to developers.redhat.com. You can create a free account, and then you can, there's a developer sandbox, or, if you scan this QR code or use this link, you'll go straight to it. And then you'll get this environment where you also have Tekton that you can use to, to deploy your application. Here's the GitOps cookbook that a very famous author wrote, right, Alex?
Yeah, this is what I mentioned before, right? You can, if you want to learn about Tekton and ArgoCD, then yeah, this book is for you. You can download it for free. Here you've got the link and the QR code. So yeah, there is no excuse to not read the book. Yeah,
and I'll share a link to the slides in the chat, or I don't know, or on our Twitter or whatever. We'll give it to you so that you have all these resources afterwards too. So yeah, definitely sign up for developers.redhat.com because you get more. There's even more ebooks that you can sign up for free. So that's pretty cool. And then there's another book. If you're a Java developer, this is also by our team members Natale and Marcus, who wrote a book on modernizing enterprise Java to run in cloud native environments with Quarkus. And then here are the links for the game here. So we have the source code for the game, for the manifests, and then the slides as well. Let me see if I can copy and paste those. Copy, and then I'll post those in the event chat if you have access to that. And that's it. So thank you already for for joining our session. I hope this was interesting to you. Tomorrow we also have a session where we're going to kind of build on this. So we're going to have a session on progressive delivery, and basically progressive delivery means that right now when we did our release, we basically did a big bang release, right? We went from tapping our phone to shaking our phone, but we went from 5 pods running the one version, and then we deployed a new version, and so we basically replaced those 5 pods. We did that, with high availability and everything, but we didn't do kind of gradual release. And so tomorrow in our session, we'll show you how you can do progressive releases, where you can say, hey, I want to release first to maybe 10% of my audience, see how everything is going, and roll out to 20%. And then we can even monitor everything, like, for example, with Prometheus or another monitoring stack, to see if there are errors, and we can automatically roll back. So you'll see that tomorrow in our session, so definitely join for that. And then I'll go, perhaps, I don't know if we want to take live questions or see in the chat. I don't know if the moderator has any suggestions. In the meantime, I'll paste the link for the slides.
Okay, I'm gonna ask if anyone has questions. También puedes hablar en español. Alex habla español, ¿quieres?
Sí. Sí, si lo quieres hacer en español, ningún problema.
Okay, so I wanted to ask, the stack that you mentioned is kind of cool. It's kind of the usual stack, but Tekton is not for me. So I wanted to ask what clear advantage or what clear thing has Tekton that something like GitHub Actions or GitLab Pipeline doesn't have? Yeah, what?
We're not hearing very well the question.
No.
Yeah.
Wait a minute, please.
Sorry. Okay.
Yeah, better here, yeah.
Yeah, can you hear me there?
Yeah.
Yes, perfect.
Oh,
Okay.
yeah, perfect, yeah.
Yeah, I just wanted to ask that, like Argo is very useful and Kubernetes is also very useful for me, but I haven't heard of Tekton before, so I wanted to ask what advantage or clear advantage do you see from Tekton compared to GitHub Actions or GitLab Pipelines, or like the user pipelines that you have directly on the version control system.
Yeah, thank you very much for the question, because yeah, sometimes people say, this GitHub Actions, Tekton. I would say that it's another option. I mean, that you can use GitHub Actions, it works. Also, it works. Tekton, the big advantage of Tekton maybe is that you're running your pipeline in the same Kubernetes cluster where you are running your application. If you're using GitHub Actions, okay, you're building your application, you're compiling your application, you're creating your container in one infrastructure, and then you're running this container in another infrastructure, which sometimes, or most of the time work, but we found some customers that they got some incompatibilities of, oh, you created a container that I created in GitHub Actions, but then when I deploy it to OpenShift or Kubernetes or on my infrastructure, then it works differently. I get some security issues or things like that. Okay, so you can use both, but the advantage of Tekton is that it's Kubernetes native and it's running in the same cluster as your application. That's, I would say that it's a big advantage.
Yeah, and it's a CNCF project, right? Since we're at KCD, that's also, you know, interesting to mention is that it's you know, part of the CNCF. Are there any other questions? And you can ask them in Spanish too. Alex,
yeah.
Alex will understand.
¿Alguna otra pregunta? No, we don't have questions.
Okay,
Thank you so
perfect.
much. We really appreciate it.
If not, you can find us on Twitter and LinkedIn and everything too. So feel free to ask your questions later.
Okay, okay. Thank you. Thank you.
All right.
All right.
Okay.
Yep. Enjoy your day and see you.